Hello and welcome to another edition of Ontology Talk. I'm Adam Pease, and today I would like to give a discussion about a paper that I actually gave a couple of years ago that was titled "In Choosing a Logic to Represent the Semantics of Natural Language." And I've included the paper reference here in case you want to read the whole paper, and I'll also give some links to the code and the data at the end of this presentation. So first, what is this talk not about? First, there are many logics that have different levels of expressiveness. We could do many lectures just on what those different logics are and their properties. I'm really just going to focus on a couple of major classes of logics. Because the thing that is relevant here is just trying to explain why we need logics that are sort of more expressive than the ones that many people would be prone to use. So I'm only addressing these sort of major logics. There are, of course, many variations. There are as many logics as there are researchers in logic. And expressiveness is not the only criterion here that matters. It's not the only possible criterion. It is what I'm focusing on. But there is a trade-off here. If you use a more expressive logic, it's likely, although not guaranteed, that across a broad section of inferences, it will perform a bit more slowly. People all the time are creating theorem provers that do better and better. They're getting faster. And so this is an area one has to track carefully. If you want to make assumptions about how fast a particular logic is, what was true 5 years ago is not probably true today. But overall, the worst case complexity, the speed of these more expressive logics is much worse than the simpler logic. That's the general trade-off. And although limitations on various logics have been studied for a very long time, especially with regard to natural language, what I have not been able to find in the literature is a quantitative study that explains what logic is actually needed in general for different corpora of natural language expressions. And I've also not seen a sort of overall metric or explanation or recommendation based on actual data as opposed to intuitions or opinions about what sort of logic one should actually use if you have a broad selection of different kinds of utterances, different kinds of sentences. I also am not going to address in this talk why it's a good thing in general to use logic to represent knowledge. I have a number of other presentations on that topic, so I'm not really going to be trying to sell you here on using logic, using formal semantics to represent language. You can get that information elsewhere on my site or from other people. So why did I want to do this? Ultimately, I was just kind of frustrated because too often I had people tell me, well, I don't need this complicated logic. I can do everything I want in a simpler logic or maybe no logic at all. And these cases that I'm talking about, somebody else might say, well, they're rare. I just don't need to worry about them. And my intuitions about this were, of course, quite different. I've believed that one needs an expressive logic to actually capture the semantics of what people are saying, but I didn't have any data to back it up. Well, now I do. So the experiment that I came up with is I wrote some code that would attempt to classify text in a quick way by the linguistic features that are apparent in that text, and which would then entail a certain sort of logical expression that might tell us whether we need one logic or another. And I used two large corpora, one very large corpus and maybe another smaller, older corpus, you might say. So the corpus of contemporary American English is quite large, and so in fact I only used one portion of that corpus, the news text section. And I did use all of the Brown corpus of English, which is quite old and it's quite small compared to a lot of other modern corpora, but it is open and free, and it's a balanced corpus, so it has sentences from speech, broadcasts, books, poetry, a wide range of different things, whereas the COCA corpus that I used was just the news text. And so my process was to also try to validate this method. How do I know that the linguistic features that I've used that are detected automatically in the program, how do I know that they're actually detecting what I expect them to detect? So out of the many thousands of sentences that I processed automatically, I also did a randomized check where I manually tried to determine which sentences entail which logical features and see if that agreed with my automatic method. And also that I took then in turn a smaller set and fully formalized, at least as far as my sense of what it means to fully formalize a given sentence in logic, using the large ontology that I've developed called Sumo. And I hope that this would express a conservative statistic about what logics are needed. For any given sentence, and we'll take a couple examples, there are many layers of meaning in a sentence, and linguists have spent a lot of time working on this sort of thing. So I believe that on any of the sentences that I've processed, one could make a case that in fact you need even more content, more expression of the semantics, and that might in turn entail a more expressive logic, not just sort of more content, but more content of a more expressive type. So I don't make the case necessarily that these statistics are as precise as they should be, but I do make the case that what I've given is a lower bound, right? You need at least this much expressiveness to capture at least the main semantic elements of the given sentences that I've processed. So it could be even in some sense worse, right? You need more content, a more expressive logic to represent these sentences. It could be an even stronger statement than the statement or the claim that I'm making as a result of this research. So just to list what some popular logics are, I mean, obviously, if you are aware of the semantic web, then you've all heard of description logics. I've looked primarily at two particular description logics within the description logic family. It's a family that's growing all the time, especially given this interest in the semantic web and its standards. New variants are emerging all the time. I didn't track all of them. I tracked the two main ones. At least my perception of what the two main description logic formalisms are. I would also say first order logic with equality, the most prominent standard in that regard in terms of an implemented language, right? There are lots of logics that are put in textbooks or in papers or proposed in some way as language standards, but very few of those actually get implemented and used widely in theorem provers. And so the TPTP family is, I'd say, the most prominent example of not only a language standard, but a language standard that is not just conceptual, it's been widely implemented. And so there are several different logics implemented in this family and used in prominent high-performance open source, fully implemented theorem provers. So one is the TPTP FOF standard, which is just generic first order logic with equality. There's some relatively newer work in various sorts of modal logics, including epistemic logic, that I think it's fair to say are part of what they call the TXF family. Those are not as widely implemented in different theorem provers, but there are implementations. And then there's the THF standard for classical higher order logic. And so Christoph Bensmueller, who you've seen on this channel, along with Chad Brown, who you've also seen on this channel, and many others, have worked on doing things like embedding these various kinds of more expressive logics in this overall framework of classical higher order logic. So a lot of exciting work that's happening there. As a side note, I've often heard criticisms, usually by people that are only familiar with the most basic logics, saying that, well, we can't use logic, we have to use probability theory or some other sort of knowledge representation scheme because everything in the world is uncertain in some sense, and logic can't deal with that. Well, that statement would have to be nailed down a lot more, and usually the people that are not familiar with the more expressive logics don't have a lot of data that would allow them to nail down that statement. And so, as a general rule, that statement is just sort of false, right? So the criticisms that I've heard of logics can't handle contradiction, logics can't handle probability or preference or any number of these things that are prevalent in human communication, that's not an accurate criticism, because the so-called non-classical logics is one way of referring to logics that are beyond first order. Many of these logics beyond first order can handle exactly those things, and we're going to see that in some of our examples. And that's why I believe that probably a classical higher order logic framework using something like the THF language is the way to go if we really want to capture the semantics of natural language. So the language features that I detect automatically with my simple code include negation. So it is not the case that blah, blah, blah. Quantification, some, many, few, all men are doing something. Some people in this military unit are doing X. Very common sorts of expressions, as you'll see. Modals such as can, may, should, or ought. Epistemics like know or want or prefer. And authorship, say and write. And especially authorship is almost ubiquitous in news text. The minister said that, the president said that, when the UN representative was saying the following. You see this practically every paragraph, certainly, if not every other sentence. And I used Stanford's Core NLP system to tokenize, lemmatize, and detect negation. I could have used Stanza, their newer version of their linguistic analysis package. And of course, there are many others, but that's just what I used. So in terms of my results, the broad conclusion that I have is that you need at least first-order logic to represent half of the sentences that one will encounter in common usage over a large sample. And you'll probably need things that are beyond first-order logic in about 40% of the sentences across a large sample. So here are just the statistics that I came up with through my automated analysis. So first-order logic has been a basis for linguistic semantics for a good reason for a long time, because it's a nice compromise between expressiveness and the sort of simplicity of computation. Right? Their methods of inference are well known in first-order logic, and you do get a lot with first-order logic. Right? You get about, by my computations, at least 60% of sentences you can comfortably represent in first-order logic. Now, if you don't even have first-order logic, you don't have basic quantification, or you don't have true universal negation, the ability to represent any sort of arbitrary complex expression, which, that's a capability you don't get in description logics, for example, then you're really missing out. You're missing out, I would say, too much of the common discourse, the common writing that people exchange. So my validation uses my particular formal ontology, which is the main topic of this channel. It's very large. It has lots of mappings to WordNet, so we have good corpus of linguistic semantics. So we're not just using a logic, but we're using a logic that's grounded in a lot of definitions for the common things that we can refer to in our world. And I also have automated translations to some of the TP-TP family of logics, so that I can take this work that I've done and run inferences in a theorem prover. For this particular exercise, I thought that there were maybe 2 sentences out of the sample of 100 that I looked at randomly, selected out of these thousands processed automatically. I thought you could make a case for about 2 of them that maybe you could come up with a simpler encoding that wouldn't require the level of expressiveness I did. I figured that's fine, that's 2%, that's not really changing my statistics. And I would also say that most sentences actually had multiple features of the more expressive logics, such as modal expressions plus negation. And in my analysis, I just had the automated system stop with the first feature that it found amongst the set. So again, I'm aiming for a conservative estimate that you need at least this much expression, this much logical expressiveness as a percentage of common sentences. And it could be you could even make maybe a stronger case for more expressiveness. So let's just take one of these examples. So here's a random sample taken from the set. It's just a waste of resources if you ask me, she said. So not an unusual sentence. So here the main thing is the expression of authorship, right? We're attributing a sentence to a person, and that sentence itself has some logical content. So in this case, it's that there are resources that are being used that do not benefit anyone, right? There does not exist P such that the resource benefits P. And that there's also a speaking event, and the formula that is the semantic content of that speaking event is in this relationship contained formula. Right? It's a relationship between an event, a speaking, and the logical content of that speaking. And here again, I could have made this even more complicated. I didn't really capture the if you ask me. I take that to be sort of a politeness wrapper that doesn't have a lot of deep logical content, but you could certainly make a case that needs to be formalized as well, and you'd have an even more complicated expression that might use even more expressive logical features. Here's another one, and sorry for covering it up with my picture, but you can always check out the paper on my website if you want to see this and many other examples that I looked at. The example sentence is, ministers were exploring several options to close that gap, but as talks dragged on Monday, no final solution appeared imminent. And the main bit of logical expression here that I would focus on is just the temporal qualification, that you have these at least two government ministers. They are negotiating during a certain period, and during the immediate future following that period, they believe that there isn't going to be any final solution. Here I even haven't captured the belief portion of it. I've just captured the temporal qualification. If you capture the belief, well, then you've got an epistemic and you have even more logical expressiveness needed. But you at the very least need an ability to say that some formula holds in a particular temporal period, and that formula says is about an agreement, or an agreement that doesn't exist yet. Right? It's saying that there will not exist in the immediate future of the negotiation such an agreement, and an agreement specifically that's the result of the negotiation. Right? It's not that no agreement in the world might exist. That would not be an accurate thing to say. It has to say specifically following being caused by this negotiation. We don't believe an agreement will exist that's caused by this negotiation, that's the result of this negotiation. So my conclusions are that you need expressiveness, and now at least there's some statistics to back it up. If somebody believes otherwise, well, they have an opportunity to use the same code and maybe mark it up in a different way, show some different logical examples, create a different process that's maybe derivative, fork my routine on GitHub and come up with a different expression, but then say specifically why, as opposed to just that my intuition is, or just asserting baldly that, well, we don't need this sort of expressiveness, full stop, without justification or evidence. Provide the evidence. Here's the framework where one can do so, or disagree with this study in a rigorous and objective way. Here are the references to where all the code is. It's all on GitHub. And here's a reference to the paper that has an appendix. You can also get, of course, the main part of the paper also at adampease.org. So thanks for listening. Hope you enjoyed this, and eager to hear your comments.